Okay, so this is part 2 of today's lesson. So now let's talk about numbering these carbons, and we're getting ready to name these compounds, but numbering them. All right, so the question here is, what it's asking me to do is to draw pentene. All right, okay, so let's draw pentene. Now, one of the things that I know is the prefix pent means that there are 5 carbons. The suffix "ene" tells me that there is a double bond in there. All right, but where is that double bond? All right, so we have to count those atoms, which I've already done. I've already put it out there. All right, so as you can see, 1, 2, 3, 4, 5. I've met my pent portion. There is a double bond there. I've got my "ene" portion, so I'm all set. Well, not truly. I'm not really done. All right. The way that I have written this actually helps us to talk about numbering carbons. All right. Now, just like I just did, I went from here all the way down to 5. That's how I count it. But I don't know if that's the best way to do that. I'm going to teach you that. Now, if you have a compound that can have multiple bonds, double, triple bonds, or what have you, it's a little tricky, especially if you have a compound where that double or triple bond can be located. The naming part of it is a little bit more complex than we said before, okay? This case, like I said, I have to indicate exactly where that double bond is in this compound, because I can have a double bond between these two carbons, of course, over here and over here as well. The nice thing, though, is that when you are doing this, you always want to make sure that your double bonds or your break in the chain, or whatever the functional group or what have you, has the lowest possible number. So instead of counting the way that we've done 1, 2, 3, 4, 5, I think counting the other way to ensure that my double bond gets the lowest possible number makes a little bit more sense. 1, 2, 3, 4, 5. And again, you may have a compound that looks like this. Now, if this double bond was over here, then of course we're going to count 1, 2, 3, 4, 5. So we kind of change it that way. So just make sure that you're paying attention to where any double bonds or break in the parent chain occurs, branch, or what have you, okay? All right, and so with that being said, because I have my first carbon here, that means the start of that double bond is on the first carbon. And so instead of just being pentene, I have to tell you that it's 1 pentene. It's on the first carbon. The double bond is between carbon 1 and carbon 2 when we're drawing this structure. Now, this double bond could have easily been between here and here, and in that case, we would say it's starting on the second carbon, so it would be 2 pentene. All right, so that's kind of how that is. So let's take a look at this example here, 2-butene, and we're going to talk about drawing structures in the different ways that it can be done. When you see that, but is 4. Monkeys eat peeled bananas, so B for but. 4 carbons. There's an ene there, so there's a double bond somewhere in the compound. I'm telling you it's on the second carbon, not on the first. And so when I draw the structure, it looks like that. Now, whether I had one here or here, that would make this 1, 2, 3, 4. It really doesn't matter which way you count because it's on the second carbon, but you do have to indicate that, okay? So that's kind of how that is. Now, that is a very large way to take. It takes up a lot of space, takes up a lot of time. It shows you all of the hydrogens that are involved, and it's a great way to represent a structure. However, it does take up some time. There's another way that we can do this. You can see here H3C, CH, double bond, CH, CH3. This is the same thing as this. This H3C represents this right here. CH, double bond between those two, CH, and then CH3. Now, you probably wonder, well, why does she have the H on the end? Now, it's not that it's wrong if you did CH3 and then CH. It's not wrong. It's just it's just showing you that the carbons are forming the bond, not the hydrogen forming a bond with the carbon and hydrogen. But again, it's not that it's wrong, it's just a better way to represent that. Okay? This is what we call a condensed structure. We can also write it like so, again, showing where that hydrogen's on the inside, but we know that it's really carbon to carbon bonding here. It's still showing the double bonds right here, but that's still the CH, CH, CH3. So either one of those would be acceptable on a test or a quiz, okay? All right, another way that you can see that same structure drawn would be like this. I kind of like that, but you don't have to do it that way. If that doesn't make you feel happy, don't do it that way. It's still showing you the CH3. It's showing you the CH, the double bonds, CH, and then CH3 there as well. All right. Another way that you can do that means the same thing whether you put it on top or right next to it. It doesn't really make a difference. You can do it either way. I like this one a little bit better. It's a little neater. You don't necessarily have to say that this is CH3. It's understood because, again, each point means that there's a carbon there, and then you have your hydrogens, but it's still showing you the double bonds. If there was another line here, that would be a triple bond. All right, and this one's my favorite. This is the best, the one that I like to show the most because I understand that there's a carbon here and there must be 3 hydrogens because it doesn't say otherwise. Each point is a carbon and I know that there's a hydrogen. I would just do my count: 1, 2, 3, 1 hydrogen, 1, 2, 3, 1 hydrogen makes 4, and then the carbon here, 1, 2, 3 to give that carbon happen. So whichever one you want to do to represent your hydrogen, you're more than welcome, or your structure rather, you're more than welcome to do so. It does say to show your hydrogens, but again, if you get it doing this way, go for it. If you prefer writing it out, go for it. Haven't even addressed the elephant in the room, how we're going to show your structures for the test or the quiz, but we'll figure something out. Maybe we'll do it like we've been doing. All right, and there's another way that you can see these same structures, and this is just showing a shortened formula. So in this one, you have CH3, CH2, 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 CH3. This structure, this compound formula right here is saying that if you were to expand the CH4 to 4 times, which is right here, 1, 2, 3, 4. I hate that this thing is in the way, but it's the same thing, but kind of a condensed format. And then, of course, on the ends we have CH3. You can do that. If you have the same exact inside in that formula, you can definitely represent it that way. All right, like the no names and the octanes and stuff like that. That would be good to do it with those. But again, it's not required. All right, so let's try some practices on these, and I'll give you the answers, I guess, instead of trying to make you guess here. 1, 2, 3, 4. So that tells me that the prefix is but. There is a double bond between these 2 carbons, so it's ene, and it's on the 1, 2 second carbon, so 2-butene. Hopefully you guys got that. This one here, 2, there are 2 carbons, so I know the prefix for 2 is monkeys eat, so F. All right, and if I were to do the formula, 2 times 2 is 4, so that tells me that that's an alkene, so there's also a double bond, ene, and I don't need to tell you where that double bond is because there are only 2 carbons anyway, so ethene is the final answer there. And then this last one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 carbons. The prefix for 9 is known. There's a triple bond, not a double bond right here, so the ending is going to be YNE, ine. Okay, so no 9. But where exactly is that triple bond? Well, 1, 2, 3. It's on the 3rd carbon. It starts at the 3rd carbon, ends at the 4th carbon. So it's going to be 3, no 9. All right. Another way that you can see these, even in this one, sometimes you'll see it written where the 3 is right before the double bond or the triple bond, known 3-ine, and it's just saying that that's where the double or triple bond or the change is happening. All right, Either one of these is acceptable on the test or the quiz. I like either one of those, okay? All right, see you guys later. Hopefully you're on the call today.